Welcome everyone to another digital archaeology group lecture. Today we have a presentation by the BECACO Research Project, headed by Martin Berger. We also have Ishak, Riali, the postdoc on the project, and Gabriel, Spautz, Vieira, and Elizabeth Rodriguez Estrada, both PhDs working on this project. So they're all jointly going to present on their progress so far. So if you would like to start.
Yeah, sure. Thank you, Alicia, for the introduction. So hello, everyone in this space. Also, hello, everyone online. I saw a couple of names that I recognize, so it's very nice to see, well, not see you, but know that you can see me. I don't know if that sounds very nice, but still. So for those of you who do not know me, my name is Martin Berger. I work here as an assistant professor, and I am part of this project, the BECACO project that I do together with these people who are on this slide, and who you'll be seeing later will replace me in your camera view for those of you online. And we thought what we present today is part of the progress of the project that we've been doing. But what is this project? So I'll give you a short overview of what the project is, what the aims of the project are, etc. And then the other people in the project will talk about what exactly this progress entails and what we've been doing. So briefly, what is the BECACO project? For those of you who know nothing about ethnographic museums, the one thing you might know is this, right? Ethnographic museums are currently in what Sir Roger Russell calls the restitutionary moment. So there's a lot of talk about, these things that we have in these museums. Should they be here? If they shouldn't, where should they be? And all of that was sort of catalyzed by this moment that we see in this slide here, when Emmanuel Macron said, well, the restitution of African artifacts should be a top priority for France and for French museums. Of course, people from source countries have been arguing for restitution for ages and ages and ages, but it took Emmanuel Macron to say this, for this to really explode in the public sphere. And this led to this long process of different countries, among which the Netherlands, drafting legislation and sort of reports on how can we proceed with colonial collections, and as we call it is in the Dutch report, at least, a recognition of injustice. So where should these things be? How should we present? How should we progress? And how should we move forward with all these things that we have in these museums? So what this led to is, of course, if you want to know how you move forward, you need to know how you got here, basically. So this led to this moment in which everybody is now scrambling to do provenance research. So provenance research basically entails knowing where an object came from, how it came to the museum, how it was acquired. And in many cases, at least in the colonial context, whether that form of acquisition was accompanied by violence, by involuntary dispossession, by basically by reasons for an object to be returned. So the issue with provenance research is that while it is extremely valuable, all the provenance research that's going on at the moment in museums in Europe today is great, is amazing, should continue. There's basically three things. One, it is very time consuming. So you go into the archive, you look at a particular thing, you need to go to a different archive, et cetera, because archives tend to be, highly dispersed. It's very localized in the sense that museums look at their own collections because that's sort of what they are paid for to do, basically. And they sort of vet their own collections to see, if things come here in an ethical way. And it's highly problem-driven. And with problem-driven, I mean that it is driven by places where we know issues might exist. So, this in the Netherlands, a lot of this provenance research focuses on Indonesia, for example, because we know there might be problems there. Latin America is very much out of the scope and purview of provenance research in the Netherlands, simply because we did not have any colonies in Latin America, with the obvious exception of parts of the Caribbean. But so all of this led us in this project to think about how can we sort of do this on a larger scale? How can we sort of solve these issues, this idea of it being time consuming, this idea of being localized, the idea of being problem driven, and move to a situation where we don't have this sort of linear line from one person to a museum, but actually this, which is much more representative of the actual situation of how objects move, right? Something goes to one person, then it goes to another person, gets dispersed, collections get broken up or reunited, and they end up in different museums. And so the aim of this project is to sort of supercharge provenance research in a sense, using different digital driven techniques. to work towards this more large-scale provenance / collections history research to understand why do objects move, how do objects move, and how are these movements of objects related to bigger social, economic, historical, and cultural conjunctures that lead to movement of objects. And so the aim of this project is to move towards sort of interinstitutional research, so no longer this local, but focusing on this broader context of, different institutions, an international view as well of provenance, so between different countries. I'll show you some of the countries that we have in the corpus in a second. A diachronic view as well, so how do these patterns of movement change over time, not just looking at a particular historical period, but looking at a diachronic development of the art market, of ways of collecting, of patterns of collecting, and a collaborative way of working. So working with museums and museums working together, and also hopefully in the future we want to work with originated communities so that we can truly move towards a large-scale provenance research that's aimed at together looking at, what are these things that are here now, why are they here, and where should they be? And as said, we focus on the collecting of indigenous Latin American material in Europe, just because that's basically my/our background. So the scope of this project is that we have about 12 museums in 9 countries. The one museum that we see on the left-hand corner here, the British Museum, is not entirely in the project yet. We didn't receive their data, so for now it's actually 11 museums in 8 countries, but we'll get there. We work, as said, with indigenous Latin American material from roughly 1850 to 2000, though that probably, time period is roughly this. We have about 400,000 objects, which I keep saying, but I never actually count how many we have. So maybe at some point we need to count how many objects we actually have. These are the museums that are participating. I'm not going to call them all out, but you'll see a slide later where you have all the names. And this is the kind of material that we're looking at, right? And so how do we move towards this sort of large-scale provenance research is by mobilizing the power of data-driven techniques, mobilizing the power of knowledge graphs. And so we're working towards building a knowledge graph that has all this information in it that received from the museums. And this is what we'll focus on today, is actually how are we working towards making that knowledge graph. We won't focus on the actual details of the collection. We won't talk about, objects from Peru, objects from Mexico. We'll just talk about data, basically. So for those of you who do not know what a knowledge graph is, a knowledge graph is basically a representation of knowledge, of data, in the form of a network where there's relationships between entities, right? So you have nodes, individual entities, such as it says here, a person, a city, a product is because this is so often using commercial environments. We don't have products, but okay. Edges, which relate the nodes to each other. So it's the relationship between the nodes. And then properties or labels that talk about those particular nodes, edges. Just a visualization of this for those of you who, like me, about 4 years ago, had zero idea what a knowledge graph is, because I've tried to learn this in the past years. See here an example I always use from the internet, where you can see that while there is, for example, no direct relationship, and I'm going to be off camera here for a second, I apologize. Well, there's no direct relationship between the Mona Lisa itself and the Eiffel Tower, for example. By taking these different steps of relationality between things, we can build bridges and create pathways that actually link different entities together that don't originally go together, but do have relations. So if we start from the Mona Lisa, we can link it to the Louvre. We can say that the Louvre is in Paris, just like the Eiffel Tower. We can say that certain people like certain things. We can include Leonardo da Vinci. And so this is basically a mapping of knowledge, right? A representation of knowledge in the form of relationships, which you can imagine when we talk about collections is super appropriate, right? Because we talk about collections coming from a certain place, being acquired by a certain person, who then might give it to a different person, might sell it to a different person. And so these trajectories of objects can be mapped really neatly into these kind of things. Now, the issue is that we don't have a ready-made knowledge graph, right? What we have is this, just endless tabular lists of structured data, at least structured data, right? That we get from museums. These are just 2 random examples. The top one is from the World Museum here in the Netherlands, and the bottom one is from the Weltkultur Museum in Gothenburg, where you see that, we have lists of names of objects, numbers, inventory numbers of objects. We have a category for, in the bottom one, the continent, and then the country, and then it says like Eastern Ecuador, and then the other one says probably Ecuador, and the other one says Ecuador question mark. And so this is what we have to deal with, right? And this is actually what we'll talk about today, is how do we move from this thing that says probably Ecuador to a structured representation of data that actually helps us query all of this data to create this bigger understanding of collections and how they relate to each other. And so what we'll focus on today are two dimensions of progress. I mean, this is not the only thing they've done, but we thought that for this particular forum, it might make sense to focus on these two. So first of all, data integration. How do we take all these different Excel sheets, because it is basically just different Excel sheets that have slightly different columns, slightly different ways of naming things, slightly different, but also wildly different in some cases. There's a lot of uncertainty, there's a lot of unclarity in them. How do we integrate all of those into a consolidated knowledge graph? And how do we connect the artifacts and the collectors that exist between institutions? Because there's, of course, shared collectors, there's shared sort of forms of culture, all these kind of things. And then secondly, data accessibility. So how do we enable researchers to query this data, knowing that most people in museums do not possess sort of the form of data literacy that is necessary to actually understand, how you query a knowledge graph. Just like me, I do not know how to do that. So how can we create tools that enable people to do that? And how can we create access to the data in new ways and shapes and forms for the general public as well, and then ultimately also for indigenous communities themselves. So having said that, that's the end of my part. The data integration, I hand it over to Elizabeth and Gabriel.
We're doing this.
Both.
Well, why are we doing all of this? We believe that a functional knowledge graph will enable large-scale provenance research, but in order to do so, we had to adapt a semantic ETL process, which stands for extract, transform, and load. That goes as follows. The first step is extracting the data from multiple museum collections. Then we transforming the data, and what we mean by that is cleaning, standardizing, and structuring it. And the last step is loading the data into an enriched semantic knowledge graph. Well, as I just mentioned, the first step of the process is the extraction of the data from multiple museums. These are all the museums we are working with. As Martin said, it's 11 different museums in 9 different countries. And of course, due to the aims of the project, we had our choices based on how well digitized the collections were. And yeah, as of right now, we had already successfully cleaned and standardized the databases of every single one of these museums.
So what are the challenges that we have faced during this process of data integration? Well, a lot. And that's specifically because museums use different ways to catalog objects. And when we are processing the data, we are dealing with the ways in which they have cataloged their objects in time. So the first thing is that there are a lot of different data sources, as Gabriel mentioned, as was Martin mentioned. The museum data comes from different files and many systems with different formats. So depending on the cataloging system that the museum has, the exports will be different. Also, there is no shared way to describe objects, peoples, and events. For example, museums tend to work with different variables or different levels of specificity when cataloging objects. For instance, when they are assigning a geographical location to the origin of an object, some museums may use country and other museums may use region, province, etc. Other things we're facing, or with challenges we're facing with is the data quality. Some data within the databases is missing, it's incomplete, it is uncertain. I think uncertainty is one of the biggest challenges. There is a lot of question marks around all the databases, which I say that question marks are very conspicuous. There is also a lot of semantic gaps. The data is very hard to connect and to understand its meaning on its own. There is a lot of interpretation required when working with the data. And it is very hard to do insightful observations about the data, just as the state in which it is. To overcome these challenges, we have implemented several processes in this transformation, in the transformation stage, which is the second part of the ETL. So it's extract and then transform, which is here. In this step, our goal was to transform the representation of the heterogeneous data into something that is event-centered. So why event-centered? That's because of the ontology that we are using, which is CIDOC-CRM. To achieve that, we have applied the getty vocabularies for event types. Event types are things like collection, acquisition, purchase, donation, etc., etc. We have also created a controlled vocabulary for the cultural affiliation entries. Cultural affiliation refers to the culture. Several objects that can be traced back to a specific culture or archaeological culture. So we have created a control vocabulary to kind of standardize that. And also we have tried to uniformize the data across the databases into this event-centered modeling. Basically, if you have to imagine a museum catalog, you will imagine that it is describing objects. Instead of describing just the objects, what we're trying to do is describe how these objects have participated in events across time. So that is kind of the uniformization or the transformation that we have had to do with the data. And then now we're gonna explain a little bit more what is this control vocabulary that we have worked on a lot, which we have decided to call the BECACO Tesoros. This is an in-progress name. So what is it? It is a reference list of cultural affiliations extracted from all the databases of the project. So basically what we are working with is a list that includes the endonyms, which is the names that cultures use to refer to themselves of the cultural groups, and also the names by which, other names by which they are known or they were known as well. As I put here, it is not a comprehensive list of all the cultures in the Americas, because that is a lot of work, but rather a thorough list of the existing entries that the museum use as cultural affiliation with cataloging objects. As I mentioned before, this is because we need to standardize the data. It is very important because there is a lot of inconsistency when museums have cataloged their data historically. And also, this thesaurus ensures that we can have standardization, but also findability, so that we can relate objects from similar cultures that are across different museums under one term or synonym terms. Also, it is very interesting because of these thesaurus, we have also had to face other challenges, which is how do we create or how do we deal with contested terms, terms that are racially incorrect or that today are not well seen. In this reference list, we have had the opportunity to think through that and try to address that in this body of work.
Okay. After many months of discussion, and I really wish it was a joke, but it's not, we came up with this structure for the thesaurus, which is encompass 3 different columns. On the column A is named culture, and obviously it's the key name of the cultures we're working with. And often it also includes the name of archaeological sites, since museums have used the archaeological sites as cultural affiliations for the objects in their collections for the last 150 years. The second column we named similar for removal, and where it's all the incorrect entries that will be replaced with the information in column A once the Ishak, the postdoc, process the data, as well as misspellings, which happens pretty often, and all the different languages, right? Since we're working with 8 different languages. The last column is the column C that we named synonym or different spellings, which in some cases cultural groups can be known by other names, and therefore they are added in the column C to facilitate the retrieval. In other cases, the same name can have different spellings, for example, with or without accent, double consonants, double vowels, special characters, etc.
So a little bit to make all of you understand how does this work and how we try to standardize the data that we are working with. And we're going to explain this through several examples, so you can kind of follow the thought process that we had. First of all, we're working with archaeological and ethnographic material. So in the case of archaeological material, the problem is that sometimes these objects are cataloged with archaeological sites, place names, or styles. So not necessarily when they are talking about culture in the catalog of a certain museum, they're not mentioning the culture itself, but for example, the pottery style. So how do you do that? How do you deal with something like that? We have put some examples there. These are both from the World Museum. So what we did is, for example, with the Moshe, we created an entry that represents the archaeological culture, and then within them we have included as synonyms anything that's like that is a archaeological site or that is a style. And also we've included in similar for removal, which is the column in the center, all incorrect spellings or spellings that include additional words that are not necessarily that are just representing this culture. So that's why it is a reference list, because if you find in a museum database, I don't know, Moshe Valls, what you're trying to refer to is to this word actually. So essentially we have to like filter and find every single iteration of the word Moshe and how they were related to other objects and add them together in this reference list under Moshe. So this is just one example of one archaeological culture.
Our second example are entries with multiple terms. Since objects are sometimes cataloged with more than one term as cultural affiliation. And when this happens, well, for cultures that are completely different, we chose to use a semicolon to symbolize the alternative, so it can only be one or the other. And this also applies to any entry with many options and where it's not clear which one is correct. For instance, if we have a Teotihuacan, Toltec, we standardized it by putting a semicolon. The second example is for the cultures that can actually be related. We chose to use a hyphen, which symbolizes their possible relation. And like Icachincha, the example we have here, which is the Tumaco-Latolita, which is a very good example because you can find many different spellings throughout all the databases. And it's a culture that had different names depending on which side of the frontier between Colombia and Ecuador you were. But after consulting the literature available, we decided to go with the Tumaco-Latolita with an hyphen. And of course, we still have all the synonyms in column C, but all the terms that didn't make any sense, we're getting, it's going to be substituted by Tumaco-Latolita.
Another good example of some of the challenges is when we have a lot of entries that are empty. So what do you do with things that have no information, but you cannot leave them empty? Also, entries that have very general terms to describe the cultural affiliation of objects. So our solution was to create something called the non-identified category and also the non-identified qualifier. Essentially, it is instead of leaving the space empty, we will put non-identified for something, or in the case of things that are very broad, like for example, there is a lot of objects cataloged as Mesoamerica only. We will put Mesoamerica non-identified simply because the non-identified is qualifying the concept of Mesoamerica as an instance that needs more specification. Because Mesoamerica is very broad, it's a very unspecified category in this sense, and it can refer to more than one pre-Columbian culture in more than one country. So therefore, we have added this non-identified next to entries that are extremely broad to solve or to have an idea of how to interpret the data in the future. Here I put a little picture of Mesoamerica. Yeah.
Well, now you might be asking yourselves, who do we think we are to be deciding how a culture should be called or shouldn't? And as Elizabeth said already, we're dealing with a lot of contentious data. So we came up with this hierarchy of sources when elaborating the thesaurus, just to make sure we are always utilizing more up-to-date terminology when available. And we divided it by, well, first, the modern authoritative sources with academic and indigenous expertise, like the ethnologue, the PB socioambiental from the Brazilian government, and the Getty vocabularies. The second in the list is the scholarly works without indigenous participations and old sources, which are a lot of times the only instances where certain cultural attributions appear, and are particularly prevalent in collections from the 19th century, which is a lot of the cases of the collections we're dealing with. The third tier is the data repositories of cultural resources like Yale's Iraq World Cultures and ethnolinguistica.org. The fourth are the encyclopedias like Britannica and Wikipedia. And the last one are the shady Christian databases that, for whatever reason, kept a comprehensive record on missionary activity in Latin America, as well as new reports and personal blogs by amateur archaeologists.
So with that, now we are going through the second part of how this data is integrated. Thank you.
The third step of ETL.
Okay. So, thank you so much for inviting us to share with you our research progress. So the last step of the ETL process is the lab. So at this step, the cleaned and transformed data is mapped to the CIDOC-CRM ontology. I will explain what is the CIDOC-CRM ontology. So we assign a semantic meaning to entities and relationships going from data points to a network of meaning. So the output of all this process is enriched knowledge graph that captures objects, events, places, actors, and periods. So the CIDOC-CRM is an international standard ontology developed by the ICOM for describing concept relationships in cultural heritage documentation. So it enables data exchange between heterogeneous museum systems. So it ensures the semantic interoperability, and it models complex connections between object, actors, events, and places, right? So in our project, we are using a sub-model of the CIDOC-CRM. It's unclear. So the first class is named activity, okay? So the provenance is modeled as a list of activities. Each activity can be either a production or an acquisition, and it took place at one or many geographic location. It is also linked to a temporal dimension. When it is production, it is linked to the object, to the main made object using the predicate was produced by, and it should be also linked to actors using this predicate carried out by. And we have two different kinds of actors. We have legal body, which to represent institutions, and we have also person. When it is an acquisition, so in our case, we have many types of acquisitions, like donation, purchase, etc. It should be linked to the object using the predicate, the transfer title of, and we need also to capture two actors, from who to who, two actors involved in the acquisition. The first actor should be the target, the source actor, and the second will be the target actor using two predicates, transform title from and transfer title to. We need also to keep the original description of each object. That's why we use the information object class, and we link each object to its original description using the predicate is referred to by. Okay. So as we are integrating many museums data, we are facing very serious problem, which is the same actor, the same historical actor may appear many times with different variations. Like for example here, we can see here different spellings, title variations. Sometimes it is written doctor, sometimes it's written PhD. Here, for example, Maria Elena, and he's just .e, etc. So we need to resolve these entities. That's why we proposed a fuzzy matching algorithm that detects duplicates and link entities into a clusters. Okay. So the algorithm starts by fetching and retrieving all actors from the knowledge graph. We have a person and we have institutions. Then it removes titles, punctuation, and extra spaces and convert everything to lowercase to ease the comparison between all these entities. Then it computes similarities between each pair using weight ratio fuzzy matching algorithm. So the function we are using here is weight ratio is a combination of many similarity measures. A similarity measure is a function that takes as an output two entities and returns a score between 0 and 1. So when these entities are similar, so the score should be close to 1, and when they are different, the score should be close to 0. Then we need to filter, so we need to keep only pairs with score greater or equal a threshold. Like for example, we can use this value 0.87, but we need to do many experimentations to find which value give better results. So if the similarity between two entities is above a threshold, so the pair is considered as a potential match. Otherwise, it will be ignored. And then using these similarities, so we can build similarity graph that we can use to create a list of clusters. Each cluster represents one historical person, and all entities included in that cluster are its variations. So let's illustrate the process using this sample. So here, for example, we have many records in the column A and B, and the column and we computed the similarity between each pair. If the similarity score is greater than a threshold, then we will accept the pair as a potential match. Otherwise, we will ignore it. Okay. Using this results, we can build a list of clusters. Like here, for example, we have 3 clusters. The first one represents a real entity, the second also, and the last one is another entity. So in order to be open for collaborations, we define a set of integration guidelines on the BECACO GitHub. These guidelines outline how museum data should be prepared in simple Excel or CSV formats to semantically integrate it to the BECACO language graph. And based on these guidelines, we developed a tool named BECAGraph. BECAGraph is a tool that takes Excel or CSV files and transforms them into a knowledge graph structured in CIDOC-CRM. This means that any museum that prepares its data according to the GitHub guidelines can directly integrate it into a semantic knowledge graph. This video illustrates an example. Like for example here, when a user creates an empty database, then the user should connect to the system. By following the guidelines, he can import his database and assign the name of the collection where these objects are currently stored. And it gives you an integration log, how many objects were imported. You can also integrate actors automatically just by following the guidelines. And when integrating actors, it produces the clusters using the fuzzy similarity algorithm. You can also integrate events. So after integrating, during the integration process, the entity resolution algorithm is executed automatically. Like for example, here it detected these 2 persons are it detected these. Stop. For example, here it detected these two variation as the same person, and this is why these two entities are in the same cluster. The first one is from Welt, here, as you can see, Welt, and the other one, for example, is I think from Basel. Yeah, there is other variation for other clusters. So we will work on the validation of these clusters. I think next month, my colleagues. So as Martin said before, so we are working also on the data accessibility problem. So after integrating, so we are working on the data accessibility problem. So museum already provide a lot of digital data through web portals, but these platforms are often limited. We cannot customize our search in these portals. Researchers can only perform predefined search, like searching for objects or collections, and cannot ask complex or contextual questions. Even when museums provide advanced tools like APIs or endpoints, they require technical knowledge that most of humanities researchers don't have. So even though the data is available, it remains unused. So data being open doesn't mean it is accessible. A data set may be publicly available in repositories, but still hard for researchers to understand or explore. So we are working on this problem using large language models. Large language models excel in natural language understanding, question answering, and text generation. However, without external knowledge, large language models suffer from hallucination. They produce inaccurate or fabricated information because they are trained on a general data, not specific domain. And also, most of them are trained on a fixed dataset and don't automatically update and know about recent events or published research. So in order to overcome these limitations, there is a strategy named graph retrieval augmented generation. So the graph retrieval augmentation is a framework that combines the knowledge graphs and large language models to enhance large language models performance by enriching prompts with relevant external data, ensuring that LLM responses are grounded in accurate information. So on the one hand, the graph connects related facts given deeper context, and on the other hand, large language models provide answers based on real verified data instead of AI guesses. But how it works? It works mainly through 3 steps. The first one is the retrieval, then the augmentation, then the generation. So when the user asks a question in the natural language, so the retrieval will translate the question into a knowledge graph query, and then it returns the relevant documents and the context of the query. Then we do the augmentation. So the LLM will receive the question of the user and the context retrieved by the retrieval, and the LLM will generate an answer based on the augmented context. So this is the process. Following this, the key benefits of the GraphRag strategy for cultural institutions is that it makes complex cultural heritage data accessible to everyone, not just data specialists, and it maintains accuracy through verified data connections. And following this process, we developed 2 tools. The first one is BECACO. It enables the user to talk with the knowledge graph using natural language. So, like for example, here you ask, for example, list all objects and their production information, like places and time. And here I, for example, specified to return the results as a table. So here we executed the graph retrieval augmentation, retrieval augmentation generation process to give this answer. For example, here it gives you for the traceability, it gives you the query generated by your question. You can explain the query, you can copy it and run it directly in Neo4j, for example. You can also export the table as CSV or JSON format. It depends on what you need later. So as you can see here, it gave all the production events with the places and the time. You can also search in the table here, automatic search. And you can also export all the results into CSV format. Let's take another example. And also when you are here, for example, I asked it to give for each country the number of objects per each country. When the LLM gives you the results, it recommends other similar question to your question just to follow the context. For example, now show me all details of a given object. For object identified as MUDEC, for example, I want to know more about this object identified as MUDEC 145. I try to specify events and actors here. As you can see here, the results is a graph. And how it detects this, it uses another LLM agent that decide whether the display should be a table or a graph. And also you can export the results to do some extra analysis later. Another tool that we have developed is BECA Narratives. It generates the narratives from the context of the object. So the first step, it's also following the graph retrieval augmented generation. So when the user asks for a query for the narrative, for the story of an object, the system will search for the context of the object, all the information related to the object, its provenance, etc. And it generates a narrative of the object. You can also transform the text to audio. So it is mainly dedicated to people with limited, they cannot read. So thank you so much, and we are looking forward to your feedback. You may stay here.
Yeah, maybe if you all want to come up and then